Hello and welcome to TwinCAT Automation Interface webinar. My name is Amol Naik and I've been working alongside Mr. Sven Goldstein on automation interface for a couple of years. So before beginning with my presentation, let me give you a quick view about content. So I've divided this presentation into 4 main topics. So first, I would like to give you a small introduction for TwinCAT 3 engineering. Some of you already know about it. They've started to work with it, but it will be helpful. And then I would like to introduce the automation interface technology, some basic definitions, how it works, some use cases, and then delve into the details so that for those of you who intend to work with it, will be clearer. And then at the last part, I would like to talk about some of the features, our roadmap, how we are continuously in progress to work with it. So to start with, TwinCAT 3 has been a huge step for us. So moving from TwinCAT 2, you already know that TwinCAT 3 now is integrated into Microsoft Visual Studio. So for us, it means just a single programming environment, debugging environment where you carry out your hardware configuration, you write your software and test it. So this is integrated into one single development environment. Of course, you can continue to work with the standard IEC 61131-3 PLC programming language, but what TwinCAT 3 offers is also the C++ interface. With that, you can program really down to the real time. It also offers us a possibility to develop your modules or typically models with MATLAB and Simulink and download it into back of hardware. TwinCAT 3 natively supports source control systems such as Microsoft's Team Foundation Server or SVN. It also offers us to utilize multi-core architecture along with CPU core isolation, and of course we support 64-bit machines. So it has given us a huge spectrum of features. For those of you who are already familiar with TwinCAT 3, a typical project looks like this. So you see that in Microsoft Visual Studio, TwinCAT is integrated. On the left side, you see a typical solution tree. It is divided into some parts. So at the top level, you see the configuration settings. So where you set your PLC task times or your task priorities, C++ debugging settings. Then you move down towards the PLC part, where you basically write your code, write your function blocks, define your variables. And at the bottom level, you see the hardware, basically where you design your network topology, you define your input and outputs, and then connect it with your hardware. So this is how it looks like in TwinCAT 3. What it means for us. So basically we have seen that traditionally people have worked with teams. So they had one or actually more software developers who had a particular task assigned to them. They used to work together. Some people worked with hardware, some people worked with software, and there was always someone who used to collect everything and then install it and commission it. This had some flaws because not everybody everybody likes to program it differently. So they basically had problems collecting the programs together because it had some errors. So it was necessary for us to basically reduce human-made errors. At the same time, to see if a lot of these human-made tasks or human-made programs to automate it somehow. So this was one motivation. The other motivation was, of course, if you're working on a complex project, then it was not possible to integrate some of your workflows into TwinCAT development environment. So basically you were not able to write some plugins or write some services according to your workflow expectation and integrate into your development environment. So that was not possible. So motivated from that, the TwinCAT 3 automation interface basically offers you some way to manage your TwinCAT 3 configurations in a programmed way. So basically with that you can reduce your engineering costs because you're avoiding a lot of human-made errors. Write some standardized services, for example, test features, unit testing, installation tasks. But not just that, you can implement your own workflows and integrate them into TwinCAT 3 engineering environment. This would basically be clearer when I introduce you some of the examples and discuss the details. So moving on to automation interface and what it means. Basically, as I said, it's just a programming interface which manages and creates TwinCAT 3 configurations for you. It is basically designed so that you reduce your engineering cost by automating some of the tasks, time-consuming tasks, and use it in the future. It is available for free, so you do not have to purchase any licenses from us. So if you install TwinCAT 3 engineering, it is there on your PC. It supports programming as well as scripting languages. Our preferred choice is basically C# and PowerShell because we basically have a lot of very well written examples or best practice articles, and that's why it's very convenient to use. Some of our samples are ready to use, so if you're developing something, you can just copy the code snippets and integrate into your application. And as I said, if you're working on a very complex or very big project, it is necessary to use some APIs that will ease the task of developing such projects. So what we understand is that combining automation interface with some other APIs such as offered by Visual Studio or Team Foundation Server or very familiar ADS APIs, it is possible for your development team to build these complex applications in reduced time and of course avoid human errors. So now if you intend to use it, how does it actually work? So this will probably give you a better idea. So you've seen the TwinCAT Solution Explorer, and it is basically a tree, and each tree has sub-items. There are also tree items, so these tree items have a very uniform structure. So each tree item will naturally have a parent and some children. It will have its own name and some particular settings. So what automation interface does is basically it navigates through the tree and configures each of these tree items according to the requirement. For example, if you are starting at system tree item, let's say at the top, and you want to navigate to the IO tree item, you can do that and then create a new EtherCAT master, for example. Or if you go to the PLC tree item, then you can create a new PLC project or add an existing one. Of course, with PLC tasks, you have the possibility to change the cycle time. So this is basically what automation interface does for you. After this quick introduction, I would like to show how it ultimately works. What exactly would be the end result? For that, I've prepared a small video. I will play it for you and explain it simultaneously. So you see basically a user interface. It offers you 3 different configurations particular to your machines, for example. You can activate or you can choose a configuration, select what your Visual Studio should do. Should it be visible? Should it be invisible? Should it do everything in the background? This you can choose, and then click on the generate button. So what will now happen is basically automation interface will open a Visual Studio in the background. It will it will load the selected TwinCAT solution, and it will start to fill it up with the contents of it. So for example, it has added a PLC project. Now it will add some libraries to it. Then it will add the function block, the main controlling logic, and then it will activate it and then start your TwinCAT in the runtime. What it also does is, if you see now, it has added a TwinCAT scope project, it has added some variable, and it has already started a scope record. So this could be a scenario if you are trying to test your code on a target in a very short time, and you want to see if it works or not. So for example, with this. So this is how a typical scenario looks like. To explain you a little bit of details, what's happening behind. So basically we have programmed this in C#, but you can choose your preferred language. If you're familiar with PowerShell, you can do it. But basically what happens is, for your required configuration, there is a database which is storing all these configurations for you. So they must be ready somewhere. For example, you have 3 different machines, and each 3 machines require 3 TwinCAT configuration. They are stored somewhere, and what this application does is basically goes through the database, picks out the desired or the required configuration, and generates the TwinCAT code for you. We do not recommend using any particular database. For this application, it was sufficient to use XML file, but if you are familiar with any other file formats or database, feel free to use it. As I said, it depends on your requirement, on your scope of service. So moving on, I would like to also show you another example, which is probably not as comprehensive as the last one. This is basically a small add-in or a plugin which will integrate into your Visual Studio and do a particular task for you. For example, a lot of our users who are developing libraries, they need some service to automatically generate the documentation for it. For example, there is a function block on your left, and there are comments attached to it on top of it, and the requirement is that read these comments and generate an HTML file for it. This would be a typical task for Automation Interface 2. So what we have done is, again, written this application with C#, but this time we've chosen Visual Studio API, and particularly this extensibility project. This extensibility project will give you a wizard where you can choose what this plugin should do. It will be integrated into the Visual Studio and carry out tasks specified by the automation interface. For example, it will go through each of the function block in your library, look out for this comment, autodoc_summary, and generate an HTML file where it will insert the input variables and the description for it. So this was a particular requirement from one of our customers, and we had done this basically to give him an idea about the usage of automation interface. So now basically you've seen the 2 extremes of the use cases. So one of them is quite comprehensive, the other one is probably a small one, which is just a plugin, and you would have had an idea about what automation interface is. But as I said, it's a very comprehensive tool, and it should be clear why you should be using it, and that's why I would like to tell you 3 typical scenarios, for example, which are very frequent for us. So the scenario 1 is basically if you are a machine builder, let's say, and if you have many machines and they are basically differing into small parameters, let's say field bus of your choice, and the remaining machine control is the same, the access configurations are same. So basically, these machines might have a small difference in their configuration, and there you can use automation interface because the main machine control is just the same one, and this is particularly what code generation demo does. Just for your information, this demo is available for download. You can use the sources in your own application, so feel free to do so. This could be one scenario, as I said. The second scenario is if you have your own workflows, if you would like to generate automation documentation system, or if a particular string, for example, should be inserted in your function blocks. This is a particular add-in scenario, so where you define your TwinCAT add-in. The third scenario goes further, and this is particularly where you construct your own abstract engineering tool. where you know what hardware you want to use, what software you want to use, and according to your users or your customers' requirement, you fuse it together to create one TwinCAT solution. This is not new to us because we have already done this in our product TS8100 TwinCAT Building Automation Manager. So this would be one way. But each of these scenarios have different level of programming effort and time involved. Another very familiar situation is that to have a particular workflow from design to installation. So this is also done by some of our users. They have somewhere a database, like I said earlier, where they can check in what configuration is required. They also have some sort of source control where their development team store their work. So what they basically do is that they open up an empty TwinCAT project. They connect to their database and see what TwinCAT configuration is required. Then they connect to the source control environment and get all the latest versions of, let's say, PLC project or libraries. And then they start to fill it up, their empty project, with all these components. They can compile it, check for the errors. If everything works fine, activate it on a local system or a target system. They can also choose to pack it in a setup and install it on a remote target later. So this is just to show you how automation interface works together with other API, for example, Microsoft TFS API, to design your own workflow, your own installation to commissioning cycle. If you take it a little further and imagine in reality how these different technologies are combining or are combined to carry out remote development, remote management, remote installation and commissioning tasks. So in this case, I've taken, this is just to show you, for example, at the bottom level, you have TwinCAT Automation Interface generating your binaries, as we've seen so far. And then you have your target system, let's say 10 of hundreds of CXs, and where you would like to remotely, let's say, deploy all these binaries. In that case, you can choose, let's say, OPC UA because it offers you a secure channel to do so and transfers your files on these remote targets. You can later connect ADS or also OPC UA with your field devices and check the status of your variables. Or you can also choose to store all this data remotely on a cloud database. That also you can do. So, for example, this is particularly what we think is a possibility, working with different technologies to help you to manage your huge projects. So now moving on, you've seen the use cases. You've already familiar with what automation interface does. A little bit in depth about it. So if you intend to begin with automation interface, there are, from our experiences, we think there are two basic approaches. So for example, there is one approach, let's say a template approach, where you have a pre-configured set of templates stored somewhere on your local repository, and according to requirements, you choose the right template and deploy it. This involves basically minimum development effort because you have everything ready, but these templates have to be maintained and they offer limited flexibility. The other approach, or the so-called from scratch approach, where you break down these templates into sub-templates, basically to finer levels, because you intend to modify them very flexibly, or you're very flexible about the settings of it. This would take a lot of development effort, but it offers you tremendous flexibility. So this is basically the trade-off. So either you go for the flexibility or you go for the development effort. To explain you a little bit in detail, so you've seen the Solution Explorer. So these templates are basically, you can imagine the Solution Explorer as a container. At the top level, you see the solution. This could be one template. So you store entire solution as a template, and as and when you require, you add it to your project or your new solution. If you break down further, you get PLC. So your PLC projects could be templates. You can store them. Or you move down to the IO level, the network level, where you store your devices, EtherCAT master, EtherCAT slaves, input outputs as templates, and then customize it depending on the requirement. This can happen also on the PLC code level, where you say you store your function blocks as template and customize them. So this is basically how you move down in the hierarchy and store your templates and become more and more finer. How does it look like in the code? So as I discussed about the configuration or the main solution level templates. So in this case, you're basically dealing with the Visual Studio. Basically just to open a new Visual Studio instance, create a solution, perhaps you have already opened a file which is existing, then you open it or you add it from a template. This could be one level. If you go down to project level, then you already have a solution. You use the system manager interface provided by automation interface, look up for the PLC tree item and then create a new child, create a new project. Then going down to the tree item level, let's say your hardware, then you navigate up to the hardware level and create a new EtherCAT master. So this is how it looks like in your code, for example in C#. So about the functionalities, so you've seen moving down to the hierarchy. So basically the system manager, the ITC system manager is basically the level 1 interface. It basically gives you access to the TwinCAT engineering, the TwinCAT XAE engineering. If you call it, you can execute certain tasks that will be performed within the engineering environment. Then it also offers ITC sum tree item interface. This basically allows you to navigate inside the solution and work with the tree item. If you go finer, then you have level 2 interfaces, which are basically the ITC PLC POU, where you access a programming unit, customize, for example, its declaration tasks, its name, its contents, its code. Or you go to PLC library, which is also a level 2 interface, for example, where you handle the libraries attached to your project, you choose the right version, you choose the repository, for example. So these are some of the examples of the functionalities provided by automation interface. Now to discuss about the ITC sum tree item, because it is very essential in developing your application. What it does is basically it offers you the navigation, the way to navigate within the tree. This is provided, for example, you have ITC system manager interface instantiated. It provides you a lookup tree item method, and inside this you provide an address to a tree item. For example, system hat task. This will allow you to navigate up to the task item and return an ITC sum tree item called task. So this is a very basic navigation way. So you can also provide the direct address, or you can navigate, for example, PLC. If they're on the same level, then you don't need the hat operator. So you can either combine everything together with the hat operator and navigate absolutely, or there is another way where this ITC sum tree item allows you to iterate over the tree item. For example, if you go to the IO device and access the EtherCAT master, let's say EK1100, and you would like to address all the input-output modules, then basically you just call a for each and then iterate over all the IO devices attached to the EtherCAT EK1100. So these are the two ways to navigate through the TwinCAT XAE engineering. Moving on actually towards the last part of it. So what I've mentioned earlier, so TwinCAT Automation Interface is basically a free tool. If you install it, install engineering environment, then it is part of it. The DLL is automatically registered in Windows Global Assembly Cache. And if you're developing a .NET project, simply add this as a COM reference and then you're ready to go. Just to give you a quick view about the features, For some of you, it would be difficult to read the details, but just to tell you that we are continuously working on the automation interface. So as TwinCAT 3 gets developed further, automation interface catches up with it. We're trying to develop new functionalities. For example, we are working on the C++ project, so it should be possible via automation interface to add or remove C++ projects, trigger the code generation, publish module. You've already seen that automation interface now supports creating and managing measurement projects. For example, you can add, remove charts, you can parameterize them, and of course start and stop record. So basically automation interface, we're trying to work together with TwinCAT 3 and support as many features, as many services possible with it. So this was about automation interface. I am very thankful for your attention, and I welcome questions from your side. So there is one question, do I have to know the EtherCAT device name exactly? And to answer that, this is each tree item is identified by a unique sub-item type, and this is very well documented in our Infosys. So if you visit it, this tree item is identified by sub-item type, and with that you can access the EtherCAT device. The second question is, what does the future version means? It means the versions of TwinCAT 3 basically. So we are now at 4018. It's getting the next versions are getting released shortly. So we are basically working with TwinCAT 3 versions. Does automation interface support setting up I/O for either types of I/O like Ethernet IP or Profibus? Yes, the automation interface does support the same I/O device types in the XAE. So basically, you should know that you basically inside the engineering environment. So whatever your engineering environment means, it's translated directly into the automation interface. So the next question is, you've downloaded 4016, is it already included automation interface? Yes, like I said, it is already available. I think for you to to start developing your application is to visit our Infosys site and download some very easy samples and start working with it. The best way is to use PowerShell because it is quick enough. So that would be my suggestion. I think I've reached the time limit, so I would take one last question. Does the Visual Studio require to develop, if this Visual Studio is required to develop TwinCAT, or is it possible to use TwinCAT IDE as? For TwinCAT 3 at least, for TwinCAT 3, you know that it is integrated into Visual Studio. So if you install TwinCAT 3, Visual Studio will be installed, a shell version of it. For TwinCAT 2, you do not need Visual Studio, so you can work right with whatever that is installed on your system. Okay, because of the time limit, I cannot take more questions, but I've mentioned my email address. You're also, some of you also are in touch with me or with Mr. Sven Goldstein. So feel free to write us, and we will be definitely be answering your questions as fast as possible. Thank you very much.